Hello, this video is going to help with lines and angles, section 11 too. And let's define different kind of lines that we probably know about, make sure we understand the definition. So let's start with parallel lines. Most of you know the definition for parallel lines. They never intersect, but you also have to know they're coplanar. So they're coplanar. Oops, I put two A's in there. Let's just blend that into my N. Whoop, whoop. Coplanar lines that oops, don't intersect. So coplanar, remember, is they're on the same plane, and then also the symbol is like two lines that look parallel. That's our symbol. So when you see that symbol, it means parallel. We get lazy. We don't want to write parallel lines. So we have a little symbol for it. The next one is skew lines. So skew lines are kind of the opposite of parallel, but they're non-coplanar. And they're not parallel. And do not intersect. I like that I use don't and then do not. You know. Okay, so skew lines, I'll draw a picture here in just a second and show you kind of skew lines. They're non-coplanar, so they're not on that same plane, but they don't intersect. So maybe one's on this plane going this way, and the other one's over here on a different plane, and they are never going to intersect because this one's like this one's like this, but they're definitely not parallel. Okay, so skew lines, and then we also have the definition parallel planes. And again, I'll draw a picture in just a second. These are planes that don't intersect. So my example of this one would be your roof and your floor. They both are parallel and they don't intersect. Parallel planes, excuse me, that don't intersect. So let's just draw a quick little picture here. Or maybe I'll just use my picture from my notes because it's way prettier than me drawing it right now. Okay, here's the picture I drew right here. And let's say, okay, we have line AD. Okay, what is parallel to line AD? Well, line BC, right? They're on the same plane. So AD is parallel to BC. What else is AD parallel to? It's parallel to EH because these two would be on the same plane and those are parallel. It is parallel to FG because you could draw a plane that you could see at the diagonal. So those could be parallel. And notice that we wrote AD is parallel to BC with all the symbols. So the symbol for lines above the BC, AC, you could do a segment also. I kind of try to make these look like lines. If we kept them a segment like we see here, you could just do a straight line across the top. It wouldn't need the arrows. Okay, so without showing you the answer, AB is skew to what? And it could be more than one. So let's see. AB is here. What line is skew? Let's remember the definition of skew. It is not on the same plane and it's not parallel and they don't intersect. So AB is here. CG would be, they would never intersect and they're not on the same plane. So that one we don't have a special symbol for. It also would be skew with DH over here. Let's see. I think that's it, just those two that I can think of right now. All right, and then plane ABCD is parallel, so this is how we'd label. The top is parallel to the bottom. We'd say ABCD, and in the same order, EFGH, those two planes are parallel. And we use usually 4 symbols when we talk planes. 4, sometimes I guess you could probably use 3, not symbols, letters. To label those. We could also say like FBCG is parallel to EADH, and you'd need the word plane in there. Okay. Are AB and HG skew? So these are some questions you might be asked. AB and HG. AB, HG. Are those skew? So again, AB, HG. Are they skew? No, they're parallel. You can draw a plane that way, right? So be careful. Most skew lines that we're looking at, one's one's this way, or something like that. Okay, so the next definition that we're going to kind of go over is called a transversal. And this is the idea of a transversal is in chapter or section 11, 1 and 2. So the transversal on this one is just a line that intersects two or more lines. That's it. So we could draw it a couple different ways. It could have two parallel lines with the transversal through it. And this is what the next section really focuses on. There's lots of rules about the angles that make them equal and things like that. So we do a lot of things with that. Or they could not be parallel lines and you have a transversal, or there could be like three and you have a transversal. And I labeled the transversals with a T. All it is a line drawn through two or more other lines. And you'll usually see it in exactly like this type of pattern. So what we need to know about those is that we have a couple different, I guess, ways to call out or label each angle that it forms when you draw this transversal. Okay, so these are not parallel lines, and we can call this T, and we can call this L and this M. That's typical what they call them. So T, L, and M, transversal, line L, line M. And then we're going to refer to all of these angles. And the big thing, notice I kind of lightly shaded in red this middle. Those are our interior angles because they're inside both lines. And our outside ones are exterior. So 7, 8, 1, 2 are exterior angles. And how are these angles related? So we have different names for each type of relationship that these have. The first one is alternate interior. It's just like you hear. Here's interior, all inside. Alternate interior are on the opposite side of the transversal. So 3 and 6 and 5 and 4 are two separate pairs of alternate interior angles. And so those are our only two sets of those alternate interior. 5 and 4 and 6 and 3. If those lines were parallel, those alternate interior angles end up being the same degrees. Okay, aren't on this because we don't have parallel, but that's what we're going to go over in the next lecture. Okay, so the next one, what about same side interior angles? So same side interior angles. 5 and 3, because they're on the same side, and 6 and 4 are interior, and they are on the same side. So 5 and... Oh, did I do that wrong? I think I said it wrong. Well, those are same side. Oh, I was doing... well, these would be considered same side, 5 and 6, 3 and 4. And those would be same side. These are considered same side interior too. I think I just didn't label all of them on my little definition there. Suddenly I stopped and went, wait. So same side interior, they are on the same side and they're interior. So these two could be as well as this way. And I didn't list them all. I'm not sure why I stopped there. So the next, and nope, one more. The corresponding angles on the same side of the transversal. So corresponding angles is kind of code for they're kind of in the same spot as the other one. So here's what I mean by that. So if we look, 7 and 3, right? These are both on the same spot on the transversal or on the lines and on the same side as the transversal here. So these are two angles, 7 and 3 are corresponding, 8 and 4, 5 and 1, 6 and 2. So they're all in the same spot, so they're called corresponding angles, and they're in so I kind of think of them as a similar position. Okay. The last one is alternate exterior angles. So alternate exterior, so just like you see alternate, so it's going to be an opposite, right? exterior angles. So here's our exterior, and we're talking alternate exterior. And so you're going through in this homework and basically labeling what angle's what, and if it's parallel or if it's skew or if it's got a parallel plane as well. So you're really labeling a lot of things in this section. Hope this video was helpful.